Now, in this video, we will going to take up one more problem on projections of solids. How to analyze this problem and solve by using the manual sketching. The problem reads as a square pyramid 35 mm sides of base and 60 mm axis length rests on HP on one of its corners of the base, such that two base edges containing the corner on which it rests make equal inclinations with HP. Draw the projections of the pyramid when the axis of the pyramid is inclined to HP at 40 degrees and to VP at 30 degrees. To do this problem, see, he says it is resting on one of the corners of its base, such that two base edges containing the corner on which it rests make equal inclination with HP. So since it is resting on corner, so obviously you need to keep the position such that the corner should come at the extreme point. So that is possible only when you are rotating the square by an angle of 45 degrees. So here, if you see, A is one corner and C is the other corner, which you can see here, A dash and C dash. And here, which is the base? The base is A dash, B dash, B dash, C dash, C dash, D dash and D dash, A dash. So these base edges are parallel to HP. Therefore, you are getting the true length in HP. That is, AB equals BC equals CD equals DA, which is the side equal to 35. And when you join the diagonals, you will going to get an apex point here, which is O dash. So these are the slant edges, that is O dash A dash, O dash B dash, O dash C dash and O dash D dash are the base edges or the slant edges. Slant edge means it is the edge which is inclined to HP is the slant edge. And here the height of the pyramid is 60 mm, the base of the pyramid is 35. So this is the apex point and the center is at this point. So obviously the axis will be O1. So when you look from the front view, A, B, C is near to the observer. So A dash, B dash, C dash is visible and D is away from the observer. So D dash becomes invisible. And O1 is at the center of the square and this is hidden by the edges AB and BC. Therefore, you have O1 dash is the in bracket. Similarly, O dash is visible where O dash is at the apex band. As you look from the top view, when you look from the top view, A, B, C, D are the extreme corners of the square. So obviously, those things will going to become visible in the top view. As we have joined between O dash and A dash in the front view, obviously you need to join between O to A, O to B, O to C and O to D. Here, O dash, D dash is invisible because O dash is a visible point, D dash is an invisible point. So visible to invisible is always invisible, but the priority should be given to the visible edge. Therefore, we have darkened O dash, B dash and O dash, D dash is also on the same edge, but it is coinciding with O dash, B dash. So you need to give the priority to the visible edge. Therefore, we have darkened this O dash, B dash. So this is how you will be able to analyze it and how to draw this on a sketchbook. So to do that, first I will going to draw the XY line and I will mark VP and HP. So here, first in the horizontal plane, you take any point with reference to the horizontal line. By using the protractor, you measure 45 degrees from the horizontal line towards the left side and also from the horizontal towards the right side of 45 degrees. And from this point, you draw a line at 45 degrees to the horizontal. Similarly, from this point on to right side of 45 degrees. Then by using the compass, you mark this point as B. By using the compass, you measure a radius of 35 and cut an arc on the 45 degree line. Similarly, from the same point, you cut on the right side also. And you mark these 2 points as A and C. From A, through A, with A as center, take the same radius of 35 and draw an arc. Similarly, with C as center, cut on the previously drawn arc to get the point D. Then join A to B, B to C, C to D and D to A with a dark line, and then draw the diagonals AC and BD with a dark line. Once you do that, then you mark the point as O and O1 in bracket, because as you look from the top view, O is near to the observer and O1 dash is away from the observer. So therefore, O is visible and O1 is invisible. So then, draw a vertical projector from each of these points to the XY line. That is from A, B, C and D. From O, you draw a vertical projector and extend it to the front view, and by using the compass, you measure a radius of 60. With this as center, cut it on the center line, and you mark that point as O dash. As you look from the front view, ABC is near to the observer, A dash, B dash, C dash is visible, and D is away from the observer. Therefore, D dash will be in bracket, and also O1 dash will be in bracket. Then join O to A dash with a dark line, O to B dash with a dark line, and O dash C dash with a dark line. Then join between A dash C dash with a dark line. So this is how you will be able to write the initial position of the square pyramid both in the top view and as well as in the front view. Then now he says the axis is inclined at 40 degrees to HB. So you take any convenient position from C dash, from the initial position of the front view, then you mark that point as C dash. As we rotate the axis by 40 degrees, what happens to the base? The base will be rotated by 50 degrees. Then from C dash, with reference to the XY line, you measure an angle of 50 degrees with respect to the XY line, and then draw an inclined line. Then by using the compass with C dash as center, take the radius of C dash A dash and transfer it on the second position of front view, and you mark this point as A dash. Similarly, from C dash of the initial position of the front view, from C dash you measure the radius of C dash B dash. From C dash of the second position front view, transfer it on that A dash C dash line. So you get this point. Then you measure the distance from C dash to O dash, which will also be the same as A dash O dash. With C dash as center, draw an arc. Similarly, with the same radius, with A dash as center, cut on the previously drawn arc, and you mark that point as O dash, and this point as B dash, and this point as D dash in bracket, and this point as O1 dash in bracket. Then join O dash to A dash with a dark line, O dash to B dash with a dark line, O dash C dash with a dark line, then from A dash C dash with a dark line. So what I am doing is, I am rewriting the same sketch by rotating such that the axis is inclined at 40 degrees to HB. If the axis is inclined to be at 40 degrees, then obviously the base will be inclined at 50 degrees. The sum of these two should be always equal to 90 degrees, or this will going to become a right angled triangle wherein this angle is 90. You know this angle which is given in the problem, it is 40 degrees, that is the axis O dash O1 dash is inclined at 40 degrees to HB. Obviously this angle will be 90 plus 40 is 130, 180 minus 140 is 50 degrees. Now, then I need to write the top view for this. How to draw a top view? Draw a vertical projector from A dash to the top view, and similarly draw a vertical projector from C dash to the top view, and draw a vertical projector from O dash to the top view, and similarly from O1 dash to the top view. Why I need to do all these things? Because I am projecting A, O, O1 and C simultaneously. Then draw a vertical projector from these points such that these four lines, that is A dash, O1 dash, A dash, O1 dash, C dash and O dash will always intersect on this horizontal line. And then you mark this point as A, and similarly when you are projecting from here, it is O1 in bracket, O1, then draw a vertical projector from C, that is to intersection at this C, and similarly from O dash it will be O. Then you draw a vertical projector from B dash and D dash and extend it, and draw a horizontal projector from both D and B. Both these two lines will going to intersect at these 2 points, and you mark this point as D and B. Then now join between A to B, B to C, C to D, then D to A with a thin line, and then draw a B to O, then D to O, C to O, and A to O. So join all these points. So once you do that, all these things are done by using the thin edges. Now you apply the condition of visibility. So what the condition of visibility says? All the exterior edges of the boundaries of the solids are visible. Which are all the exterior edges of the boundaries of the solid? So A to B, B to O, O to D, and D to A will form the exterior edges of the boundaries of the solid. So therefore you dark them. Then the edge nearer to the observer is visible. So what we are doing is, now we are writing the top view for this particular second position front view. As we look from the top view, O dash A dash is the edge which is near to the observer. Therefore you dark between O to A with a dot line. Once you do that, then next position is the edge or a corner which is on XY line in the front view is always invisible in the top view. So that means C dash is visible here, and then C becomes invisible here. Applying this condition. Once this edge becomes visible, so naturally this point is beneath this, so therefore C will become invisible. So you put it in bracket. Then from a point, if any one of the edges is invisible, automatically all other edges from that point are invisible. So that means from C you have B to C and also from C to D. Okay. Then also we have C to O. These three are the edges. But here AO is hiding this CO. Therefore, since the priority should be given to the visible edge, therefore we have darkened A to O. Now, what happens to the point of B and C and also C and D? B is a visible edge, C is an invisible edge, invisible point. Therefore, visible to invisible is invisible. Therefore, BC will become invisible. So, what happens to the CD? CD also again you can apply. D is a visible point, C is an invisible point. Visible to invisible is invisible. That also you can say. Or else, from the point, if any one of the edges becomes invisible, therefore automatically the another edge which is joining between C and D will also become invisible. And what happens to the edge of CO? Edge of CO is also invisible, but thus that CO is hidden by the edge AO. That edge AO is hiding that CO. Therefore, priority should be given to the visible edge. Therefore, we have darkened AO. And this will be, since one portion of the square of ABCD is invisible, therefore O1 will become invisible. So keep this O1 and bracket. As the axis is being rotated by an angle of 40 degrees, then what happens to the axis in the top view? The top view axis will going to become the apparent length. Why? Because once this angle, that is axis O dash, O1 dash becomes invisible, becomes inclined to HP. Therefore, O1 will going to have apparent length in HP. What is the meaning of apparent length? The length of O1 will not be equal to 60, but it will be less than 60. Since O1 is parallel to VP, therefore O dash O1 dash will going to become the true length here. Now, since here one of the corners is resting on HP, therefore I have kept C dash on XY line. Then he says the axis is inclined to VP at 30 degrees. So since the axis, the inclination given with respect to the axis of to VP is the true inclination, as we see in the second position front view. Once the axis becomes inclined to HP, therefore you will going to get the apparent length. But what I am trying to do now, I am trying to rewrite the same sketch by rotating at an angle of axis equal to 30. Therefore, since this is the apparent length and the axis given is the true inclination with respect to VP, therefore I cannot rotate this on the axis line of 30 degrees, because this is the true inclination and this is the apparent length. So I need to find out the apparent inclination. So from the projections of lines on the apparent inclination, we will going to get the apparent length. On true inclination, you will going to get the true length. Apply the concept. So consider any point with reference to the horizontal. By using the protractor, you measure an angle of 30 degrees downwards, then you mark that point, then from this point you join that 30 degree line and extend it. So this will going to be the true inclination line. Now I need to take the true length of the axis. What is the true length of the axis? Since the axis is parallel to VP, the true length of the axis is 60 mm here. This is also 60 and this is also 60. This is 60 because the axis is parallel to VP. Therefore, in VP, that axis will going to be in true length. So, by using the compass, you measure the distance from O dash to B dash, or you take the 60 mm radius with this point as center, cut on the 30 degree line, and you mark this point as O, and from this point you draw a horizontal projector to get the locus. So then you take the distance between O to O1 of the second position top view by using the compass with the same center O, cut on the locus line, and you mark that point as O1 in bracket. Then join this with the apparent length and extend it. Then as we know, this line is perpendicular to O1 line. So O1 is the inclination, is the apparent inclination beta. So from this point, by using the protractor with reference to this O1 line, you measure an angle of 90 degrees and then draw perpendicular to O1, and you extend this O1 by some distance here or the below that. Then you measure the distance from O to A and transfer it from this O onto that apparent inclination line. So you mark that point as A. Similarly, you measure the distance from O to C. From O, you cut an arc on that beta inclination line and you mark that point as C. Similarly, this you mark as O1 and bracket. Then you measure the distance from this point to D and also from this point to B. Both will going to have the same length through O1. Since you have drawn a perpendicular line through O1, you measure a radius of this D to O1, and from this you transfer it on to the left hand side. Similarly, you measure the distance from O1 to B. From O1, you cut it on below that line and you mark that point as B. Then join A to B, B to C with a dotted line, C to D with a dotted line, with a dark line between A and D. Then join between O to D, O to C and O to A, and then O to B. So you mark this point as beta. Since the axis is coinciding, the priority is to be given for the visible edge. Therefore, we have not shown the axis, but we have noted the axis points of O and O1 in bracket. So you mark this angle as beta, that is the apparent inclination line. Then I need to write the front view such that the base is near to the observer. So you draw a vertical projector from A and draw a horizontal projector from A dash. Both these two lines will going to intersect at this point. You mark that point as A dash. Then join between, draw a horizontal projector from both B dash and B dash and O1 dash. Then draw a B, D and O. So draw a vertical projector from B to this line. Similarly from O1 to the same line again, and from D to the same line. You mark this point as D dash, and you mark this point as O1 dash, and you mark this point as B dash. Then draw a vertical projector from C to the XY line, and you mark that point as C dash. Similarly, draw a vertical projector from D to the above distance, and then these two lines will going to intersect at this point. You mark that point as D dash, and draw a vertical projector from B to the front view, and similarly draw a horizontal projector which is already drawn from D dash, and then extend it to this B dash, and you mark that point as B dash. Then similarly draw a vertical projector from O1 and draw a horizontal projector from O1 dash within bracket, and these two lines will going to get at this point. You mark that point as O1 dash. Similarly, draw a horizontal projector from A dash and draw a vertical projector from A. These two lines will going to intersect at this point. You mark that point as A dash. Similarly, draw a horizontal projector from O dash and draw a vertical projector from O. These two lines will going to intersect at this point. You mark that point as O dash. Now once you do that, join A to B dash, B to D dash, B dash C dash, C dash D dash and D dash A dash with a thin line, and draw a join between O dash to A dash, then O dash to B dash, then O dash to C dash, then O dash to D dash with the thin lines. Don't dark them, and join the axis as big dash and small dash, and you mark this point as O1 dash. Now once you do that, now you apply the condition of visibility. All the exterior edges of the boundaries of the solids are visible. From O dash, join between O dash to A dash with a dark line, A dash to D dash with a dark line, D dash C dash with a dark line, and C dash O dash with a dark line. This is because these are all the edges which are exterior edges of the boundaries of the solid, which are automatically becomes visible. Then the surface nearer to the observer is visible. So what does it mean? Here the entire surface A, B, C, D, the base surface as we see here, and this is being rotated such that the apex is nearer to VP than the observer. So therefore, when you look from the front view, the base of the pyramid is totally visible. Therefore, you are already joined between A dash D dash and D dash C dash, then join between C dash B dash and B dash A dash. As we know, the base of the solid becomes visible. Therefore, O1 dash is on that base, so it becomes without bracket O1 dash. Now, from a point, if two edges are visible, automatically the third edge is also becomes visible. So which is that point? From B dash, you have three edges. One is from B dash to A dash, and the other one from B dash to C dash, and the last one is from B dash to O dash. As we know, A dash to B dash and B dash to C dash is already visible because the entire base surface is near to the observer. Where you can see that as you look from the front view, this entire base ABCD becomes visible. So once B dash becomes visible, from B dash you have three edges. One is B dash A dash and the other one is B dash C dash, and now we have an ambiguity between B dash and O dash. As we know, A dash, B dash and B dash C dash is near to the observer. Therefore, these two edges becomes visible. So from B dash to C dash and B dash to A dash is visible. Therefore, B dash O dash will also becomes visible. So you dark them. Then we have this line. The left out line is only O dash D dash. As we see, A dash B dash is visible. Since D dash O dash is crossing that visible edge, therefore apply the condition two visible edges can never cross each other. That means once A dash B dash becomes visible edge, obviously D dash O dash is crossing that visible edge. Therefore, D dash O dash should be in dotted line. So this is how. As we see, A dash, B dash, C dash, D dash, the entire base surface is visible. Since O1 dash is on that surface, therefore O1 dash becomes visible. Then join between O dash and O1 dash with a big dash and small dash line, which will going to be represented as the axis. How do I know that this problem is right? You can see even in the final position, you can see that corner is on HP, then the axis is inclined to VP at 30 degrees, so we need to find out the apparent inclination, which we have found out. Since the axis is inclined to HP, which is 40 degrees, and then the base of the square pyramid is 35 and the height of the square pyramid is 60. So this is how you will be able to analyze and solve the problem in manual sketchbook. Thank you.